Welcome everyone. In this video lecture, I'm going to give you a brief overview on clustering. We're going to look at the definition of clustering, what actually clusters are, what is similarity, some measures of finding out how good a cluster is, and the uses of clustering. So let's get started. We first define clustering. What is clustering? So according to Han and Camber book, Data Mining Concept and Techniques, I've picked up two definitions here on clustering. The first one, clustering is the process of grouping the data into classes or clusters so that objects within a cluster have high similarity in comparison to one another but are very dissimilar to objects in other clusters. That is, we're trying to say that clustering is the process of grouping whereby every element in a particular group is homogeneous, meaning the relation of that element with every other element in that group is very high, the similarity is very high, but the similarity of that element with elements in other clusters is very low. Then if you look at the second definition, the process of grouping a set of physical or abstract objects into classes of similar objects is called clustering. Says the same thing. That is, clustering is the technique of putting elements that are similar or objects that are similar together into classes. Let us look more into detail to understand this. Understanding clusters. A cluster is a collection of data objects that are similar to one another within the same cluster and are dissimilar to objects in other clusters. So what do we mean by that? Here I have two clusters. The first one is cluster A and the second one is cluster B. According to this definition and also the definition of clustering, we have to ensure that every element in this particular cluster A are similar to each other and if possible very highly similar to each other. Similarly, here every data element in cluster B have to be highly similar to each other, but any data element from A should be as dissimilar as possible to any data element in cluster B. So, a cluster has to have maximum intra-cluster similarity. So, this intra-cluster similarity has to be maximum, but inter-cluster similarity has to be minimum. So similarities and dissimilarities are based on some attributes, criteria or variable types and so on. This we have to remember. So if I say two data elements are similar, A1 and A2 are similar to each other. Now there has to be some criteria based on which these two are similar. To understand this, let us have a look at an image here. Now in this image, I have a particular task, that is to form clusters based on the items in the image. So if you look at the items in the image, all of them are food items. So I could say this is one cluster. However, if my criteria changes, alright, then I could look at this as various clusters. So let's say one of the criteria is whether the food is vegetarian or non-vegetarian. Then I would clearly have here two clusters where I would have fish, meat, egg in one cluster and I'd have all the fruits and vegetables and cereals in another cluster. Then if my criteria is, let's say, milk products and non-milk products, so I would have milk and cheese, let's say, in one cluster and everything else in another cluster. Similarly, if I have fruits as the criteria, then I would have apple, grapes and strawberry in one cluster and everything else in another cluster. So you see, when I talk about dissimilarity or similarity, these have to be based on some attributes, criteria and variable. So now if I say that, we come to another point, that is, when we talk about similarity, how do we define similarity? What is similarity? Similarity, defining it is actually a very challenging task. To understand how challenging it is, we will again have a look at some set of pictures here. So if you look at this picture of Justin Timberlake and ramen noodle, look at this picture and can I say that they are similar and they can belong to the same cluster? Well, at first glance, I'd say that yes, there is some similarity in these two pictures. What is the similarity? The pattern of hair or the texture of hair of Justin Timberlake and ramen noodle is exactly the same. The color, the texture, and the pattern. So I could say they are similar if that is the criteria. But generally, if I'm forming a cluster, I don't think so I would form a cluster of these two items together. Alright, so if you look at another image also here, I have a particular card here and I have a lady who's wearing a particular t-shirt that resembles exactly to the pattern of the card. Here also I could say these two belong to the same clusters, but generally I wouldn't form clusters like these. I would form more meaningful clusters. So though these images are similar, though the hair of Justin Timberlake and ramen noodle is exactly the same, and I would say the similarity is very high, but this would not be a good cluster. Why? Because it is not very meaningful. So when I talk about similarity, please remember similarity is subjective. Subjective to our criteria, subjective to the data objects that we are trying to group together or we are studying. Then, talking of similarity and being subjective, those two images I've taken from a particular website that I've given here below. For more of such hilarious images, you could go there. I'm just sharing the link here. So, let's come to a similarity again. We said similarity is subjective. So, when similarity is subjective, there has to be some means of finding out how good a cluster is. How good is a particular cluster? That is, when I'm doing clustering, when I'm grouping data objects, there has to be some means of telling me whether my cluster is good enough or not. So there we have scatter coefficient. What is scatter coefficient? It is just a measure of how good the clustering is that will result in preference of some clusters in comparison to other clusters. Well, there's a formula to calculate this, and the formula is such, that is scatter coefficient equal to ratio of average intra-cluster to the average inter-cluster distance. What do I mean by that? Let's just go to a previous image, this one. Okay, so here if I'm trying to calculate the scatter coefficient, what would I do here? I would find out the distance of every data object in the same cluster. So I would find out distance of A1 from A2, 3, 4, 5. Similarly, distance of A2 from A1, 3, 4, 5 and so on, and get an average of that. And then I would find out the distance from every element of this particular cluster to every element of the other cluster. That will be intercluster distance, and inside the cluster is the intra-cluster distance. So if I'm trying to find out the scatter coefficient will be the ratio of average intra-cluster, that is distance between data objects of the same cluster, to the average intercluster, distance of the objects of different clusters. So that's scatter coefficient for you. Now, if you look at this, so that's what I was going to say. That is, I find out the distance of every data object from every other data object in a particular cluster, here also, and I get the average, and then I find out the distance between the two clusters. Alright, so here please remember, the lower the scatter coefficient, the better the cluster. Alright, the lower the value of the scatter coefficient, the better the cluster. That is, the higher the distance between two different data objects of two different clusters, the better the cluster. Alright, okay. Then What are the uses of clustering? There are various uses of clustering. Clustering can be applied to various areas. I've just listed a few here. In market research, pattern recognition, data analysis, image processing, and then there are so many others. In market research, maybe I would like to cluster customers, all right, to find out exactly, okay, this is the group of customers that buys a particular product, so I would like to reach out to them if I'm launching a product like that. Or this is a group of customers whose living index is so and so, so if I launch a product that they can afford, I would first go to them, things like that. And then pattern recognition, data analysis, image processing, and so many things. All right, example, let's say for natural language processing, I would like to form clusters of punctuations in a paragraph, so that also would be use of clustering. Now, some of the uses I have highlighted here is clustering is also called data segmentation. Now, why is it called data segmentation? Clustering partitions large data set into groups according to their similarity. So if I have lots of data, clustering helps me in grouping this data into smaller and more meaningful clusters or groups based on their similarity. Then clustering can also be used for outlier detection. Firstly, what is outlier? Outlier is a value that is far away from any cluster. That is, outlier are values that are not similar to any of the clusters or are as dissimilar as possible to other clusters. Like let's take here. All right, so let's say I have a particular value C, data element C, and C is not similar to anything in A, C is not similar to anything in B, then I would say C is an outlier. C is an outlier. So clustering can be used for outlier detection also. Now, an application of outlier detection would be credit card fraud detection. For example, suddenly you find out that a particular transaction is happening that usually does not happen, a transaction that does not belong to any existing group in the past. So that could be reported as an outlier, and then the fraud could be detected. Then another use here is clustering may serve as a pre-processing step for other algorithms. In data mining, actually there are various algorithms that use clustering right at the beginning for pre-processing. Example I had already given you in natural language processing. Clustering could be used to maybe find out stop words, punctuations right beforehand, before starting or working with the data. Alright, so those are some uses of clustering. There are many more uses. I've just listed a few here. Then, to end up this overview on clustering, I just want to bring into notice how is clustering different from classification. Now, classification is supervised learning. That is, you already have predefined classes and you put data elements into these classes as they fit in. But clustering is non-supervised learning. That is, clustering, all right, is a form of learning where you learn by observing. You learn by studying each of the data objects and trying to find out the similarity between them or the dissimilarity between them. All right, so to end this particular video, I would put up this sentence saying that clustering is a form of learning by observation rather than learning by examples. And that is how clustering is different from classification and more challenging than classification, because we do not have already the predefined classes where we can just put in data elements. So that was all with this particular overview of clustering. In case you have any questions, please feel free to comment below, or you could also reach out to me at the email address that I have given here. In the next video, we will look at requirements of clustering in data mining.